All right, in this video lesson, we'll be converting degrees to radians and radians to degrees. All right, previously, we saw some generic things we need to apply. First, pi radians, 180 degrees, or simply, pi is the same thing as 180. Also, pi over 180 is equal to 1. What that means is if we just said that pi is the same thing as 180, anything over itself should equal 1. You'll see as we move forward how we will apply this particular ratio. Well, if pi over 180 is 1, 180 over pi is also 1. And again, you'll see shortly that these will be the fractions that we will apply or use as we convert between degrees and radians. All right, so the first one says convert 150 degrees to radians. Well, we're going to build off of a general understanding that we know that any number multiplied by 1 gives us the same number, the identity property of multiplication. Why am I doing this? It's because I should be able to take this 150 degrees and multiply it not necessarily by 1, but by a form of 1. That's what these two red ratios will be used for shortly. So here's the train of thought. Because I don't want degrees, so I'm trying to convert from degrees to radian, I'm essentially trying to cancel or remove the degrees. How will I do this? I'm going to multiply it by one of these two fractions, the fraction that has degrees in the denominator. Why? Because if degrees is in the denominator, when we multiply, degrees will cancel out. So if the degree has to be in the bottom, that means the 180 will be in the denominator, and the pi, because of this, and pi will go in the numerator. So we are essentially taking 150 degrees and multiplying it by a form of 1. This particular format will cause the degrees to cancel out. And so when we multiply straight across, 150 times pi all over 180. So we just have to take the 150 over 180 and simplify. So 150 over 180 is 5, 6, which means our final answer is simply 5 pi over 6. So 150 degrees converts to 5 pi over 6 radians. And as illustrated in previous videos, if there is no unit, it's understood to be radians. And 9 times out of 10, if you've got pi, you're working with radians. All right, so we'll try a different one. Now, this is converting radians to degrees. So, again, we'll start with the same premise that any number multiplied by 1 gives us the same thing. And so we're going to use a version of 1. So, if I take the 11 pi over 4, because it's in radians, because I got the pi, if I'm trying to convert from radians to degree, I don't want the pi anymore. So I'll multiply by one of these versions that has pi in the denominator. Well, it's obvious this is the one that has the pi in the denominator, so that forces me to put the 180 on top. Why am I doing this? Because when I multiply, the pi's will cross reduce. They will cancel. And so I'm left with just the numbers. 11 fourths times 180. So this is the only math that's going to occur. 11 fourths times 180. Calculator says 495. So therefore, 11 pi over 4 radians is 495 degrees. And I didn't necessarily have to write the word radians here. So again, if I summarize this, to convert radians to degrees, we simply multiplied by 180 over pi. Again, if we're going from radians to degrees, that means we have the pi. And so to eliminate the pi, it went on the denominator. The second thing was to convert degrees to radians, multiply by pi radians over 180, or simply pi over 180. Again, Because if we're starting with degrees, we don't want the degree, so the degree would have to go in the denominator. So I'll do a few problems just to illustrate. It says convert each degree measure to radians and each radian measure to degree. All right, so for the first one, 13 pi over 9, we obviously don't want the pi. Pi has to go in the bottom. If pi is in the denominator, 180 is on top. So that leaves me with pi's cancel. So this is the math that occurs. 13 over 9 times 180, 260 degrees. Done. Next one, we're trying to get rid of the degree. So therefore, we want degrees in the denominator. Hence, pi over 180. Degrees cancel. We're left with 135 pi over 180. There's the math. Leaves me with 3/4 is what the calculator will say when we just put the pi in the numerator. Because the 135 over 180 reduced to 3 over 4. Next one, we don't want pi. Pi goes in the denominator, means the 180's on top. When the pi's cancel out, we're left with the math, 23 over 18 times 180. Calculator tells us 230 degrees. Last one, we don't want the degree, so therefore degree goes on the bottom, pi's on top. Degrees cancel, leave me with 15 pi over 180. So the math is reducing the 15 and the 180. 15 divided by 180 is 1/12. Now please notice, as I'm dividing, I am not writing decimals. Everything is in fraction form. So if your calculator gives you a decimal, tell it to convert it to a fraction. So if we look at this, if we look back at each one of the problems, in the first one, we multiplied by 180. Second, divided by 180. Multiplied 180. Divided 180. So it illustrates that in the conversions, you're either going to multiply by 180 or divide by 180. Sometimes you'll see a substitution method, meaning this. We realize pi is the exact same thing as 180. So some methods say, well, if you see pi, simply substitute 180. And that would leave you with 13 times 180. So it kind of illustrates, this is the one I would multiply by 180. Again, you don't see any pi. Chances are divide by 180. So with every single one of these, it's either multiplying by 180 or dividing by 180. Awesome. Hopefully this helps as you do some practice.